So yesterday we talked about translations, which are slides, sliding horizontally and vertically. And today we're going to talk about a flip. So flipping a figure over so it is a reflection is the official word for it. It is a transformation where the object is mirrored over or across a line of reflection. The notation for it is a reflection is a capital R, and it is the subscript is the M, which is the line of reflection, whatever it is. So it might look like this, a reflection over the x-axis. So whatever it says right there, that is the line that you're going to flip it across. So let's look at some problems with this. Use this triangle DEF to find the image coordinates after the following reflections. So my pre-image started at 4, -2, E is at 7, 4, and F is at 8, -4. So I want to reflect it across the x-axis. So the x-axis is right here. So when you're going to reflect it, flip it over, what you want to do is you're going to maintain the distance away from that line of reflection. So if you'll notice, D is 1, 2 below the line of reflection. So when we flip it across and put it on the other side of the x-axis, it's going to go 2 above it, 1, 2. And so D prime will be right there. So my new D, my image of D will be right there at 4, 2. E is at 7, 4. It's 4 above, so it will be now 4 below. Notice that its x value didn't change, but its y value became -4. And then we have, that's my E prime, and then my F prime was at 8, -4. It's 1, 2, 3, 4 away from that line of symmetry. So it will be 1, 2, 3, 4 above it. And so my new F, my F prime, will be at 8, +4. Okay, so we'll talk about the rules for that in just a second, but let's get an idea of what happens when we reflect it across the y-axis. So the y-axis is right here, and we want to do the same thing. We want to maintain the distance away from our line of reflection. So if I'm going to flip across the y-axis or over the y-axis, then I am going to maintain that distance perpendicularly. So 1, 2, 3, 4, 4 away. So 1, 2, 3, 4. And I put my dot right there. So D is now at -4, -2. And we went back to our original figure, if you notice. E was 1, 2, 3, 4, 5, 6, 7. So it'll be 1, 2, 3, 4, 5, 6, 7. There is my new E prime. It is at -7, 4. And then F was 8 away, so it will be 1, 2, 3, 4, 5, 6, 7, 8. It will go right here. There is your new F, F prime, and it is at -8, -4. Now, you always, when we're doing these on a coordinate graph, you always have the opportunity of using the coordinate graph anytime you want. But you also have the opportunity of using the rules. And sometimes the rules are just quicker. They don't require as much counting. And so you can also use those. So let's take a look at what that means. So let's look at from my pre-image to my image when I reflected across the x-axis. Notice what stayed the same. X value stayed the same, Y became the opposite. X value stayed the same, Y became the opposite. X stayed the same, Y became the opposite. So what that will look like is my rule, whatever my coordinate was before, this is my pre-image, will become, my X value will stay the same, and my Y value became the opposite. And we use a -Y to represent, or a negative to represent the opposite. So it's not saying it's going to be negative. It's saying it's going to be the opposite of what it was before. Okay, so make a note of that. That negative doesn't mean it's going to be negative. It means if it was negative, it's going to become positive. Okay, now let's look at our Y from our pre-image to our image. Notice that when we flipped over our Y-axis, notice it's moving horizontally. That's why our X value became the opposite, but our Y value stayed the same. Opposite, same. Opposite, same. So my pre-image, xy, whatever it was before, is going to now become the opposite of x, and my y value will stay the same. So those are the rules. And so you can just start with your pre-image, and if you know your rules, then you don't have to draw anything, you don't have to count anything. All you have to do is actually change the values of your numbers. Okay, now what if we want to reflect across y is equal to x? Y is equal to x has a y-intercept of 0. It goes through 0, 0. It has a slope of 1 over 1. It looks like this. If I can get it to draw in, get a couple of dots on there because it's not always square. So here is my y is equal to x. So let's look at what happens with y is equal to x. So this one is definitely one that you're going to want to use the rules for. It's way easier than trying to figure out where it is. Now, remember that distance away, I'll show you where it comes from, but distance away is perpendicular. So I need to flip, I need to maintain my distance from D to the line. But notice it can't be perpendicular. It's not as easy as it was before when we could just go horizontally and vertically. So here's the easiest way to do it. If we go up 1, 2, and then over 1, 2, 3, 4, then that's my slope from D to a point that's on the line, right? So what you want to do is just mimic that. So I went up over 4. So now what I'm going to do is I'm going to go over, up 2 over 4. I'm going to go over 2, up 4. So basically I'm just going to zigzag that opposite reciprocal slope, right? Up 4, or excuse me, up 2, back 4, and then I'm going to go, excuse me, I got lost. So then we can say that that's going to go here, -2, +4. So we just went in opposite directions. So notice that I found my D that way, right? I could do the same thing with F. I want to go over or up 1, 2, 3, 4 over 1, 2, 3, 4, 5, 6, 7, 8. So what I'll do is I'll go back 4, 1, 2, 3, 4, up 1, 2, 3, 4, 5, 6, 7, 8, and it'll go right there. That's your F prime, your new F. And then your E, we would go up 1, 2, 3. It should have hit right here. And then it just hit there, so we'll just go over 1, 2, 3, and then that's where your E prime will be. So notice, let's put back our original so you can see what happened. Our original was at 4, -2. That was our pre-image. 7, 4, and 8, -4. So if you go and you look at your D, now your D is at -2, +4. Your E is at 4, 7, and your F is at -4, +8. So that's what it maintained its distance. It's perpendicular. If you look, that line right there is perpendicular to it. And that's what we wanted, was that perpendicular slope. So what you do now is, notice, look at this rule right here. Look at what happened. All they did was trade places. So you can do the same thing. If you wanted to reflect across y equals -x, then it's the same premise, right? You just line it up. You can do the same thing that we did before using those slopes, but it's complicated, right? So here's what we want to do. If follow the rules, so D was at 4, -2. So what we want to do is notice that when it was y was x and y traded places. So we can come down here. So x, y becomes y, x. So if you want to reflect across y equals -x, then the only thing that happens is the x and the y trade places, x becomes y, and y becomes x, right? It says y is equal to x. So the y value, the y position now becomes the x value, and the x position becomes the y value. That's what's happening. The x position becomes the y value, and the y position becomes the x value. Now, if it's y equals negative x, you're going to do the same thing, except now, yields, right? Your x position becomes your negative y value because it was negative x, and your y position becomes your negative x. So y equals x, they're just going to trade places. Y equals negative x means they're going to trade places and change signs. And it gives you the hint, look, y is negative x. Y is, this is my y position, it is now negative x, which means x is negative y. So x becomes negative y. So y becomes negative x, and x becomes negative y, or y becomes x. So that's why this one's easier just to do it by memory, because if you have to go over here and you do these slopes, then you're likely to mess it up counting it and getting the perpendiculars right? So it was originally at 4, negative 2. So I'm going to flip the numbers. So it's going to be a 2 and a 4, and I'm going to change the signs. Remember, it doesn't stay negative. It becomes the opposite of what it was before. So it was a positive 4. Now it will be negative. It was a negative 2. Now it will be positive. Okay, E was at 7, 4, so you're going to trade their places, 4 and 7, and you make them the opposite of what they were before. They were both positive, now they're both negative. And then F, you're going to change the numbers, so your Y value becomes your negative X, the opposite of X, which would be negative 8, and your X becomes the opposite of Y, which would be positive 4. Okay, so these you definitely want to memorize the rules for these. I personally think the rules are easy for all of them, but we're going to have a lot of rules on this unit, so that can make it a little more complicated. But particularly this rule right here, but it tells you, the rule itself tells you what to do. Y becomes X, X becomes Y, Y becomes negative X, X becomes negative Y. Okay? So now let's look at some more. This is done where, same thing, it's just now a little bit different in the way that the problem is written. So instead of telling you what to reflect over, I am actually going to give you the rule and ask you if you recognize what's happening. So notice it goes from xy to x negative y. So notice what changed. Y, the y value changed. If your y value changed, if only your y value changed, then all you're doing is flipping from here to here, okay? So this is a reflection over the x axis, or y is equal to 0. Either one, depending on how it's worded, okay? So if we look at our pre-image, A was at 2, 1, B is at 6, 2, and C is at 4, 5. So if we use our rules, now again, you can always reflect it, but again, look right here, it tells you exactly what to do. X stays X, Y becomes the opposite. So X stays X, Y becomes the opposite. X stays X, Y becomes the opposite, and X stays X, Y becomes the opposite. That is the benefit of recognizing how to use this rule. You don't have to draw anything. You don't have to count, because we make a lot of mistakes when we're counting. Okay, then we have xy becomes negative y, negative x. So look right here, y became negative x. So that is a reflection across y equals negative x. Again, let's just use the rule that they gave us. xy becomes negative x and negative y. So they're going to switch places and become the opposite of what they were. So 2, 1 is going to become negative 1, negative 2. They switch places and become the opposite. B becomes, switch places, negative 2, negative 6, and become the opposite. And C becomes negative 5, negative 4. They switch places and become the opposite of what they were. Okay, so understanding the rules, understanding what this looks like and how to use it is really beneficial. Now, what if you are reflecting across something else? What if it's not x-axis, y-axis, y equals x, or y equals negative x? What if I want to reflect across y equals negative 2 or x is equal to 3. Now this is where the graph comes in really handy because these these rules are a little bit harder to keep up with, but some of you might still prefer the rules in this case. So let's take a look. Our pre-image, remember that D was at 4, -2. We're back to our original picture. E was at 7, 4, and F was at 8, -4. Now, it says to reflect across y is equal to -2. Y is equal to -2 is a remember that OI and VUX, that is a y graph, which is horizontal, and it passes through -2. So here is my y is equal to -2. Now remember, what we want to do is we want to maintain our distance from the line of reflection. Notice that D is sitting on the line of reflection. So basically, it just spins around that line and it doesn't go anywhere. So D, if you reflect it across y equals -2, it stays at 4, -2. It doesn't move because it is 0 away from that line, and so it will remain 0 away from that line. Now notice E was 4 above the x-axis, but it is 6 away from the red line. Basically, what we're doing is we're just shifting our axes down, right? So it is 6 away, so it needs to be 6 away from the red line on the flip side of that. So 1, 2, 3, 4, 5, 6. So that is where your new E prime is going to go. So D and D prime are in the same place. E prime is at 7, -8. You name it according to the origin, right? We locate it according to how far it is away from the line of reflection, but we name it based off of its normal address on a coordinate plane. And then F is 2 below, so it will be 2 above it, so we'll move up 2 from the red line. So it was 1, 2, so it will be 1, 2, and that is at 8, 0. Now, can we come up with a rule for this? Yes, absolutely we can. So notice what didn't change, right? So your x values, when you reflected across the x-axis, your x values stayed the same. So my x values stayed the same. Your D value is going to be the one that we really can't look at. So let's take a look at E. Notice what E did. So it went from 4 to -8, and F went from -4 to 0. So here's how we can take this into account. Our normal rule is that x, y becomes, when you reflect across the y or the x-axis or something moving in that direction, your x value stays the same and your y becomes the opposite. So we're going to do the same thing. We're going to change our y to be the opposite, but we need to take into account that this shifted down. So what we do is we have to double up that 2. Right? So we have to double up. It's 2 away from the axis above it. So we have to double this up. So what we'll do is we'll do 2 times -2, and that'll give me -4. So then I could have used a rule that if you recognize, okay, it's in the direction of the x-axis, which means your y value is going to change, and it's going to go twice whatever that value is, then you would come up with these same numbers. That's why I'm saying it's easier to do it on the graph than it is to do with the rules. The other 4, they're easier to do with the rules. Now, what if we reflect it? Like, let's do this one with the rules. I'll show you what it looks like real quick, but then let's do it with the rule because I think it'll be a lot easier. So we're going to reflect across x is equal to 3. X is equal to 3. That's that VUX rule, right? Vertical line, x is equal to. So we want a vertical line through x is equal to 3. That's where we're going to maintain our distance. All right, so D's 1 away, so it's going to be 1 away on this side. So now D will be at 2, -2. Now let's talk about it. So we're reflecting across x is equal to 3. That is similar to reflecting across the y-axis. So that's xy, right? X changes and y stays the same. When you reflect across something that goes in the direction of y, the y-axis, then it's going to maintain that same thing. So my x is going to become the opposite and my y is going to stay the same. So just like before, your y value is going to stay the same, just like my x value stayed the same when I reflected over something that went in the x direction, the x-axis. Okay, but now what we're going to do, we're going to change our x value, and we're going to change it, we're going to add or subtract 2 times whatever my value is. So 2 times 3 is positive 6, so I would say plus 6. So my y value is going to stay the same. My x value is going to become the opposite of what it was, and I'm going to add 6. And again, you don't have to do it this way. You may certainly count. E is 1, 2, 3, 4, so it's 1, 2, 3, 4, and you name it based off of its origin. You are welcome to do it on the graph that way. And I would prefer actually to do it that way. So if we do E, though, we're going to change. So that would be negative 7 plus 6, which is negative 1, and 4 stays the same. F, we're going to change it to be opposite. Negative 8 plus 6 is negative 2, and then the y value stays the same. Okay, so couple of things to remember, right? When you reflect across the x-axis, x stays the same, y changes. When you reflect across the y-axis, x changes and y stays the same. When you reflect across y equals x, your y value becomes your x value, your x value becomes your y value. And then if it's y equals negative x, they trade places and they change signs. Okay? Again, when you do something other than one of those 4, it might be easier to do it on a grid, and all of them can be done on a grid.